Hi people of the internet, welcome to this new video by the Natura. Sorry if I'm recording this with the Skype webcam again, but that's what we got and it's left to do for now. So, today I wanted to talk about a philosophical topic that many people I know discuss about, and I wanted to tell you what I think about it. And this is the gnoseology of math. What's math, really? Well, the first thing that probably pops to mind is nothing else but a set of arbitrary symbols to which we assign symbolic meaning. Like, for example, we create a random symbol on paper, we call it two, and we decide that it means two. And we associate it to the concept of like two apples or two trees or something like that. And then in math, we have some rules to work with these arbitrary signs referring to intuitive concepts, and then we work with these and on and on. So, and there are two big questions arising from this vague idea that you've probably got about math. And these two questions that many people ask are one, is math discovered or is math invented? And second, and this is a very related question, as you probably guess, um, why does math work? Because in this framework, what is math? Well, it's an arbitrary set of symbols to which we assign arbitrary value. That's something people build, right? I mean, there is no such thing as two or equals in nature. That's just an intuitive concept we got that we associate with things that are in nature. In nature, we've got two apples, of course, but there isn't the concept of the number two in nature, right? So math doesn't really exist on its own, does it? But if that's the case, it's created by us, it's something we invent. But if that's the case, how does it work? I mean, if it's really just one language that we've got, why does it using that language tell us something that is true about the universe? And here you may ask, is it really true? And it really looks like it is, because I just take math, so I take something that people invented, or maybe discovered, I do stuff with that, and I get other symbols, like the solutions to an equation, right? It's just taking a symbol, a set of symbols, which is an equation, and, well, not every set of symbol is an equation, but an equation is a set of symbols, doing stuff with that according to rules which ain't really arbitrary, but don't really seem to come from, like they don't seem set in stone at the very least. And then what I get is still a symbol, the solution to an equation, but then that symbol is telling me something about nature, because if I do an experiment, what I found out during the process of solving that equation is related, is describing what an experiment is telling me. For example, in math, I take an equation describing a real world situation. I solve the equation, and solving the equation, I get what I get in the real world situation as well. For example, stupid example, I do some math, and I find out that the area under a curve under a curve that is describing the shape of, I don't know, a string. Okay, I get that I do math, the calculus, I compute an interval, and I get that the area is a certain value. Then I measure the area in real life, which is under the said string, which maybe lies on a table or something. And what I get is the same thing I got with math, but a very abstract thing like math, set of symbols that people invented, is accurately describing reality. How is that possible? This and is math discovered or invented are the question that we're going to, try to find an answer to in today's video. Let's make it so. So, I think that what we really have to do here is to work on that math is a language thing. because I think that that is the pivot point of the whole thing. I think that in the sentence math is a language, we've got the whole answer to both our questions. Now, we have to understand that most language behave in arbitrary ways, right? I mean, for example, I'm speaking English right now, and the rules that make English grammar work are mostly arbitrary. I mean, I've got a slap, an ass, and a verb if I'm talking third person, but there's nothing about the universe as a whole that tells me I have to do it. Okay, but and earlier on, I described math in a very similar way. I said that neither math rules are set in stone, which is obviously true. No God has descended upon us, telling us that this is how computing integrals work. And obviously, we have theorems that make all the rules we use come from somewhere. But those theorems are based on assumptions which are ours and still feel arbitrary, right? Well, not quite. I mean, I think that saying that math is a language should be the framework for a much deeper analogy between the way we work with math and the way we work with other languages. I don't think that we should compare math's rules to grammatic. I don't think we should create an analogy between the way an integral is computed and the way a verb is conjugated in a language, even though math is absolutely a language, and being a language, it's invented in the same way any other language is invented. I think that the rules of math are the rules via which we go from one sentence in the language of math, which is, for example, an equation, which is obviously a sentence in the language of math, to another sentence, which is another equation, which could be an equation telling me what the solution to the previous equation was. For example, x equals pi squared. Okay, that's still an equation, but is also telling me the solution to a previous equation. Okay. Now, I think that we should think of maths rules as the rules that tell me how I can go from one sentence, aka one equation, the first equation, to another sentence, aka x equals pi squared. For example, the solution to the equation, the conclusion. Therefore, math rules must be taught as much more similar to the rules of Aristotelic logic than to the rules of any other language in terms of grammatic. For example, if I tell you that my brother always sleeps on Saturday, using Aristotelic logic, you can conclude that if it is, I've just said that if it's Saturday, my brother is sleeping. So, using the rules of Aristotelic logic, you can conclude that if my brother is not sleeping, then it's obviously not Saturday. Okay, that's Aristotelic logic. Are you gonna tell me that you don't know how something arbitrary as the English language could come to a conclusion that has something to do with the inherent nature of the universe? Well, maybe will, but that's not really a question that is as natural as the ones we posed before. Because what you said, your reasoning worked because your logic was not flawed. Your reasoning worked because it obeyed the rules of Aristotelic logic and logic in general. So the question that we're really asking when we ask ourselves why math works is why logic works. That's the point. The fact that math is a language is not the reason why it's awkward that math works. The fact that math is a language is the reason that it is natural that math works. Because the fact that math works is absolutely analog. It's absolutely the same as any other logic expressed in any language, English, Italian, Russian, whatever, in general. So, why does math work? Because math is really Aristotelic logic expressed in another way. Well, maybe not really just Aristotelic logic, that's logic. Logic has its specific branch of philosophy. And so, why does math work? It works because that's logic, and logic works. Which brings us to another crazy hard question, which is why the heck does logic work? This is basically the main question of gnoseology, isn't it? We are basically asking ourselves, how do we know anything about the universe? And here we're really not posing the question in the right way, in my opinion, because in the question itself, we are already assuming we know something about the universe. We are already assuming that logic works, which assumes that our empirical understanding of the universe is not inherently flawed, because if it was, how could we know that logic works? Maybe that's just an illusion. But if I'm assuming that the empirical way of analysis that humans and other animals have works, then I could just say that logic is based on that, and therefore it must work too. I don't think this is too much of a good approach, because I think that gnoseology is much more complex of a thing than that. I well, gnoseology wide, I think that the best approach to this is the one by Immanuel Kant, is in his Critic of the Pure Reason, 1781, which isn't really just about this question in particular. It's about a great bunch of philosophic questions. It really wants to rebuild gnoseology from the ground up, to solve a lot of conflicts in philosophy. But I think that he also answers this question pretty well. How does logic work? Well, logic kind of works. It doesn't really, we can't really say that it predicts the true nature of the universe, because we don't really know what the true nature of the universe is. We know the universe by a filter, which is the one of our senses. Many people would argue that my eyes predict the world as it is, but that's not really true, and quantum mechanics has just told that to us over and over and over and over again. We see the world, but what we really see, well, maybe is the world as it really is. Most likely it's a shadow of how the world is in reality. We just have no way of knowing, and knowing the world in itself beyond the distortion that our eyes, ears, skin, and anything apply is just hopeless, because our senses are the only way we know the world directly, and therefore, what else can you do? So you don't know that what you see, you hear, and everything is true. You just have to assume it is. And that is also the thing you put logic, you use as a reference to determine if logic is true or not. In the example of the area under the string before, you use your senses, you use empirical analysis to understand what the area under the string is in reality. So you constantly assume, and that's just an assumption, that what your senses perceive is true. But so with skepticism, so we say that we can know nothing at all. Well, not really. Not really, because our perceptions are very constant. Our perceptions tell us the same thing every time we take a measurement over and over again. And so it just makes sense to believe that's not something we know, that's something we assume, because it makes sense to assume it at this point, that if we don't change and what we see doesn't change either, probably it's not an illusion. Probably we are really seeing but an approximation of what reality is. It's really just like looking at a shadow. I have an apple. I can't see the apple. I just can see the shadow of the apple. But this doesn't mean I know nothing about the apple. I know the shade of the apple. And if I look at the apple's shade from many, 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 many different perspectives, at the end of the day, one day I'll be able to tell you how the apple really is. Will I ever know the apple on itself? Well, no. But I can know the apple, and what I know is not false, it's not an illusion, it's true. So we can know things about God. So why does this bring us with the original question? Well, if we can know reality through empirical senses, and since empirical analysis is the first step of knowing, right? I mean, it's the first step of knowing the world, and then we build things there from the ground up. Empirical analysis gives us the bricks that we use to build up our understanding of the universe. Then we put these bricks together to build up this understanding, and the rules by which we put these bricks together are the rules of logic. But these rules do not come from the bricks themselves, they come from the builder, which is us. We build them in a certain way because we want a certain understanding, and we build them that specific way because that's what our mind requires. That's how our mind works. Logic is based on categories, and categories, either Aristotelic or Kantian, do not come from the world, do not come from the universe. They come from the framework of the mind. But again, it is the intellect doing this, and the intellect does this working with the material that comes from empirical analysis. And being this material an approximation of the truth, which is a kind of truth, this works. This gives us another approximation of the truth, because we are just taking approximations of the truth and arranging them in a certain way. And so logic works. And math works because it's logic. Math is just like logic. There's no difference whatsoever. There's no questions asked at all. Obviously, here maybe I should correct myself a little bit. I said that the bricks we put together come from empirical analysis. Actually, just a couple of those bricks do. Others come from intuition. Others come from, concepts known a priori, but also the categories are known as a priori. But this doesn't really change anything about what we said so far, but I wanted to point it out. And that's also the reason why, if you wanted to think transcendentally, aka without basing what you are assuming, without basing what you are saying on empirical knowledge, if you wanted to do that, gnoseology wise, you'd have to be much more careful, because you do not have that empirical basic that guarantees you that logic is actually going to work. In fact, a core point of Kantian philosophy is that logic, as we know it, if applied to non-empirical concepts, isn't guaranteed to work. We can still do something with that. We definitely can. Many people say that Kant doesn't believe that, but those people haven't actually understood a major part of Kantian philosophy. You can still do something with that, but this doing something isn't getting to the truth. This doing something is getting an idea of what you should do and what you should assume, but it's not getting to the truth, neither to an approximation of the truth in the same way that you do when you use an empirical base for your understanding of the universe. Now, you might be about to reply, but wait, you said that logic works because logic builds up from empirical knowledge, but we know nothing about math empirically. Everything we know about math, we know a priori, right? So how does this work? And that's a fair question, and I think that the answer is pretty easy to find. Simply enough, I've said that we get that with standard logic, so not math is logic obviously, but with logic based on things we know empirically, I said that we get to an approximately true conclusion because we have empirically an approximately perfect knowledge of the objects we are studying. But approximately perfect doesn't really make sense linguistically, but I think that's the idea of what I want to say. Now, in math, do I know the objects I'm studying? Yeah, of course. I know them a priori, and if I know them a priori, I do know them. I do know them very, very, very well. And therefore, I know the bricks I'm putting together. And if I know the bricks I'm putting together, when the rules of the way I put them together ain't really arbitrary, but they're dictated by the nature of my mind, and when applying the rules of my mind, of how my mind works, isn't really an arbitrary choice, but is just respecting the conditions of the model I'm applying because I'm using my mind and I can't respect the rules of my mind when I use my mind. It would be like applying a mathematical theorem without its conditions being verified. Well, since all of this is true, the rules of how I put the bricks together are still reasonable. They ain't arbitrary, they are just the rules of how my mind works, and those must be respected, and it makes sense that if they're respected, everything is fine because I'm still using my mind, so it's not arbitrary. The bricks I'm putting together, I know they aren't illusions. They ain't something I've created with my. They are kind of something I've created with my mind because I know them a priori, but they ain't something that is fully. They ain't an illusion of knowledge. Here's the point: they ain't something I think I know without really knowing it. Like it could be the idea of God. Those bricks are concepts I know infinitely well because I know them a priori. How well do you know what the number 2 is? Well, you know it infinitely well because you know that a priori. Therefore, if when applying the rules of logic, when I do logic with my language, is just reasonable is just reasonable, and when I apply to things I know approximately perfectly, I get conclusions that are approximately perfect, which is what happens when we apply logic with our intellect, and therefore when we use logic applying it to stuff we know empirically, it only makes sense for the gnoseological condition of the bricks we use in math to be conserved since the rules of logic we apply still hold. I think that the best way to say that is this. We can have a theorem here, okay? Let's just propose this theorem, the random natura theorem. When the rules of logic you apply are justified, can't but be applied, they must be applied in the system you're working. If your assumptions are true, your conclusions are true. If your assumptions are false, your conclusions are false. Whatever is the gnoseological conditions of your assumptions, so will be the gnoseological condition of your answer. What is a gnoseological condition? Do you know it? Do you assume it? Or can't you know it? Those, well, do you assume it and can't you know it are very similar, but do you know it? Do you assume it? Do you not say anything about it? Okay, when those rules of logic hold that way, if your premises you know them, your conclusions you'll know them. If you assume your premises, your conclusions will be assumptions. If you can't say anything about your premises, you have those premises and you think about that, but you don't really know if they're true or not, and everything. If that's the case, the same for your conclusions. That is true when the rules of logic are justified and can't but work in that situation. And when can the rules of logic be such that they can't but work in a certain environment? Well, simply enough, when those rules of logic are required by the way your mind works. And when are they required? By how your mind works? when your mind does actually have the bricks, does actually have the blocks to build uh, something. Okay, and this happens when you know the objects of your reasoning. Okay, and this is true when you know the objects of your reasoning empirically, and in that case you know them approximately, and therefore by deriving through a theorem your conclusions will be an approximation of the actual ideal truth, or you know your bricks infinitely well, which means you know them a priori, like in math, and in that case, your assumptions will be known a priori and will be your conclusions will be valid a priori and therefore will be valid under the same framework. Remember, math, I mean, the number two doesn't exist in nature, it exists in your mind. And so, by the argument to a theorem, your conclusions ain't about nature, they exist in your mind. But the number two is a reflection of something that actually exists in nature. Okay? And therefore, by the rerum natura theorem, the same must hold for your conclusions, and therefore math works. And I think this also answers the question, is math discovered or invented? If you want to phrase exactly why, you can say it in the comments below, but I think that's pretty clear. This video is already way too long. I hope you enjoyed this. I hope that you got what I meant. I hope you agree with me. If you don't, you're obviously wrong. See you in the next video. Hope you enjoyed it. See ya, man.